Hello learners, welcome to this session. In this session, let us discuss on application of computer vision. And these applications I had divided into two sessions. In the first part, we will see some examples and some real world examples, and then in the second part, we will be seeing the sectors applications. So, in the previous session we had learned about the computer vision, what it is, how it is different from machine learning, machine vision, etc. I am Professor V.V. Subramaniam, Director, School of Computer Information Sciences, IGNOU, New Delhi. So, in the earlier session we have seen what is the basic difference between the human vision and the computer vision, or else how they are similar to each. So, computer vision is based on an extensive set of diverse tasks combined to achieve highly sophisticated applications. The most frequent tasks in computer vision are image and video recognition, which basically consists of determining different objects an image contains. So, here we can see different tasks that the computer vision does, like image classification, identification. Likewise, there are several tasks that a computer vision technology does. One of that is image classification. Probably one of the most well known tasks in computer vision is image classification. So, it allows for the classification of a given image as belonging to one of a set of predefined categories. The best example we can give here is the Google images. So, if you are searching some images categorically or else some classified images, you can observe that a particular set of characteristics that it contains will appear onto your page. Or else another example we can see, let us take simple binary example. We want to categorize images according to whether they contain a tourist attraction or not. So, suppose in this particular example of Eiffel Tower, suppose that a classifier is built for this purpose and the image below is provided. Like you can see on the right hand side I had provided the image. The classifier will respond that the image belongs to the group of images containing only the tourist attractions. So, similar kind of towers or similar kind of monuments or pillars will be displayed whenever we use such kind of technology or else such kind of search using the classifications. So, this does not mean that it has necessarily recognized the Eiffel Tower, but rather it has previously seen photos of the tower and it has been told that those images contain a tourist attraction. So, the other task that it does is the localization. So, suppose we not only want to know which tourist attractions appear in an image, but are also interested in knowing exactly where they are. So, that particular task comes under the localization task. What is the goal? The goal of localization is to find the location of a single object in an image. For example, in the image of Eiffel Tower has been localized. You can see here. So, a red box is contained and that particular box is called as the bounding box. The standard way to perform localization is to define a bounding box enclosing the object in the image. Localization is particularly useful task. It can allow for the automatic cropping of objects in a set of images, for instance. If it is combined with the classification task, it could allow us quickly build a data set of images of famous tourist attractions. So, this particular task comes under the localization task. The other task for the computer vision does is the object detection. So, if we imagine an action involving simultaneous location and classification repeated for all objects of interest in an image, we end up with object detection. In this case, the number of objects an image can contain is unknown if it contains any at all. The purpose of object detection is therefore to find and then classify a variable number of objects in an image. I will show you one example also here. You can see In this particular object detection, you can see each and every a person, road, and then hoarding, NASCO, so NAS QAC. So there are several kinds of things wherein which it is trying to detect, like a car, a road, footpath. Likewise, each and everything is detected. So there is a kind of computer vision sensor or a camera holding, like hanging over on the other side of the road, and it is capturing and it is continuously detecting the objects whichever are moving over there or stationary itself perhaps. So you can see even the shops, banners, everything is being detected over here using the computer vision technology. So in the dense image, we see how a computer vision system identifies a large number of different objects like cars, people, bicycles, signboards, and then the text that is there on the signboards, everything. So the problem would be complex even for a human. Suppose if you are visualizing the same thing by standing over there, you may be ending up seeing something, and some parts you may not be like visualize. So, but that is not the case with the computer vision. However, it is trying to detect each and every object that is captured in the frame and try to derive some meaning from it. So, some objects are only partially visible, either because they are partly outside the frame or because they are overlapping each other. Also, the size of similar objects vary greatly. Suppose if it is very like passing very near to the camera or the sensor, then the size of the object almost varies with the, like the same car which is traveling outside that particular shot. So, this particular size also varies very greatly. A straightforward application of object detection is the counting of the objects. The applications in real time are quite diverse, from counting different types of fruits harvested to counting of some people, cars, or else passengers, or else the pedestrians moving or crossing the like the road, etc., can be easily demonstrated. So the other task that we have is the object identification. So here object identification is slightly different from the object detection. Although similar techniques are often used to achieve them both, there we are using the counting kind of thing. In this case, given a specific object, the goal is to find instances of said object in images. So in the object identification, we have to specify one particular category or else a car only. So those particular instances can be counted. So here the basic goal is not to identify or else not to go for the each and every kind of object detection. However, here we are trying to identify how many instances are there for a specific object. So it is not about classifying any image as we previously seen, but about determining if the object appears in an image or not, whether in the particular frame that particular object appears or not appears. If at all it is appearing, how many instances. So these kinds of things will be used using this particular object identifying task. So an example may be searching for images that contain the logo of a specific company. So another example we can quote here is monitoring real time images from security cameras to identify a specific person's face. So here you can see a very good application is there. So identification of a person using the computer vision technology. So the other task is the instance segmentation. Instance segmentation can be seen as next step after the object detection. So in this case, it is not only about finding objects in an image, but also about creating a mask for each detected object that is as accurate as possible. So I will quote one example so that you can understand in a better way. So in France, the law prohibits exposing children in the media without the explicit consent of their parents. So using instant segmentation techniques, it's possible to blur out young children's faces on television or in films when they are interviewed or captured outdoors, as may be the case as during student strikes. Like here, it is using the instant segmentation technique, so that whatever the targeted object is there, it is trying to mask. So, such kind of algorithms are available, and this particular algorithm is applied in France in order to prohibit exposing the children in the media. So, the other task that we can discuss is the object tracking. So, the purpose of this object tracking, the name itself says that it is to track an object that is in motion over time, utilizing consecutive video frames as the input. This functionality is essential for robots that are tasked with everything from pursuing goals to stopping a ball. In the case of goalkeeper, suppose if the goalkeeper is a robot. It is equally crucial for autonomous vehicles to allow for high level spatial reasoning and path planning. So, here you can see this particular task is different from the other tasks like object identification, object tracking, and other kinds of things. Here this object tracking is, it is tracking an object that is in motion over time. So, that also can be captured utilizing the consecutive video frames as the input kind of thing. So, similarly it is useful in various human tracking systems, from those which try to understand customer behavior. This particular customer behavior kind of thing detailedly we will see it in the next session as a case study. And as we saw in the case of retail, to those which constantly monitor football or basketball players during a game. So, it is a kind of thing wherein which it is capturing the whole movement kind of thing, object. Suppose if you are targeting a player, so that particular player will be continuously, during his play continuously it can be tracked. At the moves, the movement, everything can be particularly captured and can be studied in later on stages also. A relatively straightforward way to perform object tracking is to apply object detection to each image in a video sequence and then compare the instances of each object to determine how they are moving. The drawback of this approach is that performing object detection for each individual image is typically very expensive, because it has to target only one particular person, it has to track, it has to see, it has to identify first of all, it has to detect, and then it has to move upon in order to capture that particular person or object perhaps. So, an alternate approach would be to capture the object being tracked only once and then discern the movements of that object without explicitly recognizing it in the following image. So, this is a second kind of thing, second kind of approach or method. And finally, an object tracking method does not necessarily need to be capable of detecting objects, it can simply be based on motion criteria without being aware that the object is being tracked. So, these are the three kind of approaches one should follow, one can follow in order to track the objects. So, let us see how this particular computer vision works, because in quite one or like in the earlier discussion, in the earlier sessions discussion and this session's discussion, we are quite often using the term called as the computer vision algorithms. So, one particular algorithm for your better understanding I will discuss over here in 4-step process, and this deep learning method and techniques have profoundly transformed computer vision along with the areas of artificial intelligence to such an extent that for many tasks its use is considered standard. So, in particular convolutional neural networks, that is shortly we call it as a CNN, have achieved beyond state of art results utilizing traditional computer vision techniques. So, we will follow a 4-step approach using this CNN. In the step 1, create a data set comprised of annotated images or use an existing one. So, this is the first step. Annotations can be image category, pairs of bounding boxes and classes, or a pixel wise segmentation of each object of interest present in an image. So, this particular thing comes under the step 1. So, in the step 2, extract from each image the features pertinent to the task at hand. So, this is a key point in the modeling of the problem in deep learning. For example, what are features? The features used to recognize faces, features based on facial criteria are obviously not the same as those to recognize tourist attractions or human organs. So, there are various kinds of features that needs to be tracked upon depending upon the inputs. We have to see the features, we have to extract the features, and we have to use those features in order to recognize the objects or the human faces. So, in the third step, train a deep learning model based on the features isolated. So, training means feeding the machine learning model many images that will learn based on those features how to solve the task at hand. And in the fourth step, evaluate the model using images that were not used in the training phase. By doing so, the accuracy of the training model can be tested. So, this particular thing CNN model I had explained very briefly in 4 steps. But when you start writing the algorithm, when you start writing the applications and other things, it may have a complexity kind of thing, wherein which it involves you to derive the logic, and then you have to identify the feature set and etc. So, after talking all these tasks that the computer vision does, let us focus on some examples or else some case studies. So, one such case study is business applications. So, in the business applications, let us start with the visual search engines. So, visual search technology became available to the public with the appearance of Google Images back in 2001. Earlier, if you can see, when they launched the Google search engine, it was meant to search a particular pattern. It used to give only a kind of text box wherein which will be keying in the pattern, and then depending upon the pattern it used to extract the pages and list the pages as per their order. So, nowadays you can select the category also, like all, web, images, videos, likewise clip art, likewise you can select the category also. So, a visual search engine is able to retrieve images that meet certain content criteria. So, that is the job or goal of the visual search engine. So, searching for keywords is a common use case, but sometimes we can present a source image and request that particular images be found. So, here you can understand not only the pattern that we can give along with the search. However, if you input an image and then if you want to identify certain images which are very much similar or near to that, that is also possible with the visual search engines. So, in certain cases it is possible to specify more detailed search criteria, such as images of beaches taken during the summer containing at least 10 people. So, all these things are also possible with a little more effort using this visual search engine. So, the most well known visual search websites are, one is Google Images, Bing and Yahoo. For the first two, a set of keywords or an image can serve as the search input, but for the latter a reverse image search is to be done. Yahoo always search by keywords and the results are usually equally impressive. So, the next application we can discuss is the face recognition in Facebook. So, this is the best use case in order to recognize the faces on the Facebook. Even you are I hope you are also experiencing the same thing. This is the most common application, which is perhaps to recognize a person in an image or a video. This is especially so with security systems, but it also comes into play in social media when adding filters to faces, in photo management systems to be able to search by person, or even in preventing a person from voting more than once in an electoral process. So, these are the applications of this face recognition, one in the social media and one in the electoral processes likewise. Facial recognition can also be used in a more sophisticated way, such as to recognize emotions in the facial expressions. So, the next example that we can quote here is the Amazon Go. So, tired of waiting in line at supermarkets and grocery stores? Amazon Go stores are incredible experience. Suppose if you take the example of any supermarket. So, with the help of the basket or the cart, we can move around, we can pick the objects, we can place the objects in the cart, and there will be, after collecting or after purchasing, after picking out all the products, we have to stand before a long queue in order to get them billed. But in Amazon Go, it is not the way, it is in the reverse way. Like you pick, collect, place it in the cart and just walk away. So there are no lines or shipping boxes, all made possible thanks to the power of computer vision. So the idea is very simple. Customers enter the store, choose the products they want and leave the store with them without having to queue up to pay at the check stand or the self-check kiosk. So this particular technology that they are using in Amazon Go is called as Just Walk Out by Amazon. So this technology is called as the Just Walk Out technology. Next thing is, and forgot to say, the payment issue. So the payments will be automatically done. So suppose if you had inputted in the before, or else it may be having some sort of sensors wherein which automatically from our credit or debit card the payment will be deducted. So the other application that we can discuss is the Tesla autopilot. So this particular Tesla autopilot is different from that of the autonomous vehicles that we are going to discuss in the next session. So this Tesla's autopilot technology provides autonomous driving features that are very convenient, but this is not purely autonomous. It is not completely autonomous system as Uber's autonomous vehicles it possess, but rather a sophisticated driving assistant that is authorized to drive the car on specific route segments. So this is an important point that the company emphasizes. It is the driver's responsibility to control the vehicle under all circumstances. So this particular thing is called as the Tesla autopilot feature using the computer vision technology. So the another application or use case we can see is the Microsoft's Inner Eye. So in the health sector, Inner Eye by Microsoft is an incredible valuable tool that assists radiologists, oncologists and surgeons who work with the radiology based images. The primary goal of this particular tool is to accurately identify tumors among healthy anatomy in 3D images of cancerous growth. So this is a kind of technology that they are using for the cancer detection. So in this particular session, what we had studied, we had seen several tasks which a computer vision does, like object detection, tracking, likewise. So several kinds of techniques we had seen, and an example CNN model, how to derive it and how to use that CNN model that we had seen. Apart from the theoretical part, we had focused on real time use cases that are available in the market, like Google Images, Microsoft's Inner Eye, likewise Tesla's autopilot. So these are the use cases, live use cases that we had seen. In the next session, let us focus on the applications wherein which we divide it by the sector wise, like the retail sector, inventory, defense. Likewise, we will try to categorize all those applications and then we will focus where this particular computer vision technology can be used. So with this, I hope you had understood the tasks of the computer vision and then some use cases which are available in the market. So with this, I will conclude this particular session. Thank you. Happy learning.